Hi everyone. In this video, we're going to work through a Year 12 stats question from the AS sample paper. And this question is about outliers and also linear regression. So Sarah was studying the relationship between rainfall R millimeters and humidity H% in the UK. She takes a random sample of 11 days in May 1987 for Lucas from the last dataset. She obtained the following results. We have the rainfall and the humidity labeled in the table. Sarah examined the rainfall figures and found that Q1, the lower quartile, is 0.1. The median Q2 is 0.9 and the upper quartile Q3 is 2.4. A value that is more than 1.5 times the interquartile range above Q3 is called an outlier. Show that R equals 20.6 is an outlier. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level maths topics that will come up in your 2027 exams. So now that the 2026 exams are finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018 and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up to the app and you'll be able to access all of these 2027 predictions. So what we're going to have to do with this question, we're going to have to work out the interquartile range, which is Q3 take away Q1, times by 1.5, add that to Q3 and see if this 20.6 value is more extreme than the number we will calculate. Let's do part A down here. So interquartile range, hopefully again, you know this is Q3 take away Q1. Now, Q4 was 2.4, Q1 was 0.1. Okay, so 2.4 minus 0.1, so 2.3. So this means that Q3 plus 1.5 lots of the interquartile range is going to be the 2.4 value plus 1.5 times this 2.3 that we just worked out. And if we do this on the calculator, 1.5 times 2.3 plus 2.4 is 5.85. Now, this value, if we go back to the question again, the value that we were trying to show is an outlier is 20.6. Now, clearly, obviously, 20.6 is greater than this boundary value of 5.85. So therefore, 20.6 must be an outlier. Perfect, brilliant. So that's the first part to the question done. Now let's go to part B. So for part B, give a reason why Sarah might include this day's reading, and then for part II, exclude this day's reading. So let's start with, of course, the first one. Why might Sarah want to include this 20.6 value? Well, it's a data value, I guess, isn't it? It's a data value. It's one of the data values collected. So if it is a data value collected, then it makes sense to analyze or to make use of all of the recorded data. Okay, so we can say something like that in our answer. So we can say for part B, part I, since 20.6 is a recorded value, we may want to make use of all the given data. So if we've got a set of data, then even though this 20.6 is quite big, it is still a data value. So, you know, we should investigate or make use of all of the data given. Some kind of reason like that would be fine for this question. Now let's go to part two. So why might we not want to include it? Well, this 20.6 is very extreme. It's, I mean, if we go back to the data for the rainfall, I mean, this 20.6 there is very much bigger than the rest of the data. So because it's such an extreme value, we may want to not include it because this may affect, this may affect our analysis because it's such a big value compared to the rest of the other data. So we can say that 20.6 is much more extreme than the other data for rainfall. So let's say this can wildly impact, for example, the mean and standard deviation. Okay, so if you've got a really big value in your data, well, that's going to obviously skew the standard deviation and the mean upwards since it's much bigger than the rest of the data. Okay, great. So something like that, again, for part 2 should be fine. Now then, let's go to part C. So Sarah decided to exclude this day's reading and drew the scatter, or the following scatter diagram for the remaining 10 days values of R and H, as we can see on the scatter graph there. Give an interpretation of the correlation between rainfall and humidity. Now, because I'm running out of space kind of down here, I'm going to write my answer literally under the question. So give an interpretation of the correlation between rainfall and humidity. Well, kind of looks like as the humidity is getting bigger, the rainfall's getting bigger. It's not necessarily a strong positive correlation, but generally it looks like as the humidity is increasing, the rainfall is increasing. So if we just say that as the rainfall increases, let's say as humidity increases. So we want to say as the independent variable increases, the dependent variable increases. So in other words, as the x-axis increases, the y-axis increases. So as humidity increases, rainfall increases. So you can say that this is a positive correlation. Again, it doesn't look like a very strong positive correlation, but it's still kind of, as humidity is getting bigger, rainfall is getting bigger. Great, so that's part C. Just another quick interjection. If you are currently doing Edexcel A-level maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. Now for part D, the equation of the regression line of R on H for these 10 days is given by that equation there. So we have a straight line graph. R is equal to minus 12.8 plus 0.15H. Give an interpretation of the gradient of this line. Okay, so the gradient of the line, and I'm going to write my answer up here because again, I'm kind of running out of room down here. Let's write the answer part D up there. So remember the gradient again is change in Y over change in X, or in this case, change in R, because R is the Y-axis variable, over the change in the change in H, the X-axis variable. So we can say that gradient, just as, I mean, you don't have to write this down in your answer, but I'm explaining where this comes from. So you can say the gradient is equal to the change in the rainfall over the change in the humidity. So the gradient represents the change in rainfall for each unit of humidity. So we can say that the 0.15 represents the extra rainfall in millimeters per extra 1% of humidity. So that is what the gradient is. It is the change in the Y value for every 1 unit of the X value. So basically, as you add on 1% extra of humidity, that means the rainfall increases by the gradient of 0.15. Hopefully that makes sense. Now, for part E of the question, comment on the suitability of Sarah's sampling method for this study. So if we think about what she's done, if we just scroll up here, she's investigating the relationship between rainfall and humidity in the UK. Now, what has she done? She's taken a sample of 11 days in 1 month of the year in one location in the UK from the last data set. Now, really, if you're studying the relationship between rainfall and humidity in the UK, you would want to take data from different locations in the UK, not just one location, and maybe different months of the year and different years. Okay. So obviously in the last data set, you've got data for 1987 and 2015 between May and October. So you can take data from more months and more locations and both of the years available instead of just 1 month, 1 year, and one location. So an answer like that will be fine for part E. So let's just write this down here. I'm going to write it down over here just so we've got, because we've got no room. So Sarah has only investigated data in one UK location in 1 month and year. Okay, so that's the first part of the question. And then for the second part of the question, suggest how Sarah could make better use of the last data set for her study. So you can just say with this one, take data from more UK locations. So take data from other, or from the other, I'll say in my answer, from the other UK locations. Or again, you can say use other months of the year. You can also say that as well. If I just rub out this T here. So use data from other months and 2015 as well. Perfect. So hopefully that does make sense. If you do have any questions, feel free, drop a comment below, and I'll catch you in the next video.